The table represents a linear or exponential function. We're asked to find the equation of the function. So the first step is to recognize whether the table represents a linear function or an exponential function. If the pattern in the function values is repeated addition, we have a linear function. If the pattern in the function values is repeated multiplication, we have an exponential function. So looking at the table, notice how the x values increase by 4. Let's see if we can determine the pattern in the function values. The function values go from 1 to 5, 5 to 25, and 25 to 125. Because 1 times 5 equals 5, and 5 times 5 equals 25, and 25 times 5 equals 125, the function values have a pattern of repeated multiplication, and therefore we have an exponential function. We can say f of x is multiplied by 5 every 4 units, or every time x increases by 4. The equation of an exponential function can be given in the form of f of x equals a times m raised to the power of x divided by k, where the ordered pair 0, a is the vertical intercept. We also say a is the initial or starting amount. M is the multiplier, which is the factor that we multiply by to find consecutive function values in the table. And k is the interval for which the multiplier gives the output, which is determined by analyzing the x values in the table. So let's work on determining the equation of our function, again in the form f of x equals a times m raised to the power of x divided by k. So looking at the table, notice how this column here gives us the ordered pair 0, 1, which is the vertical intercept, and therefore we know a is equal to 1. The pattern in the function values is multiplying by 5, which means m equals 5. And then k is the interval for which the multiplier gives the output. Notice how we multiply by 5 each time x increases by 4, and therefore k equals 4. This is all we need in order to write the equation of the exponential function. We now know f of x equals a, which is 1, times m, which is 5, raised to the power of x divided by k, which would be x divided by 4. In this case, because a is 1, we can simplify this and write f of x as f of x equals 5 raised to the power of x divided by 4. Before we go, let's verify this graphically by graphing f of x on the coordinate plane and making sure it passes through the points given by the ordered pairs in the table. So f of x is graphed here in red, and notice how from the graph we can see it does pass through the first 3 points given in the table, and therefore we can assume it would also pass through the 4th point, and therefore the graph does verify our work is correct. I hope you found this helpful.